This is our first video on one-dimensional motion, right? So one-dimensional motion or any type of motion is called as kinematics. So what is kinematics? Kinematics is a Greek word, not an English word. Kinematics is made up of two words called kinesis and matics. So what is the meaning of this? These are the Greek words. Kinesis means motion or movement and matics means pertaining to. Anything pertaining to motion comes under the field of kinematics, right? Just like you know mathematics, anything pertaining to maths is called mathematics, right? So kinematics comes under the mechanics part of the physics, right? So now we talk about something called motion of an object in kinematics, but remember that in kinematics we only talk about motion of an object. For example, if I throw this marker, how this marker will move, that is what we will talk about. Okay, we will not talk about what caused the marker to move, right? Of course I threw this marker, that is the reason it moved, but we do not go into that details of what is causing that motion. We will only analyze the motion, right? For example, moon is moving around the earth in a circular way, right? Circular motion. We will talk about that motion, but we will not talk about who is making it to move like that, right? What forces are involved, right? We will not study in that. Okay, so first thing that you should know about kinematics is, while what is the definition of motion basically? A motion of an object, what is it mean? See, if an object changes its position over time, then it is said to be in motion, right? When an object changes its position over time, okay? When an object changes its position over time, then it is said to be in motion, right? And if the object doesn't change its position over time, then it is said to be at rest. Okay, so now look at this. Suppose this is a marker, right? If I throw this marker, of course its position is changing over time for me as well as you. For both of us, the marker is in motion. Now look at this whiteboard. The whiteboard is not going anywhere. That means the whiteboard is at rest with respect to me as well as you. Now see, motion and rest are not absolute concept. Something will be at rest for some person, but not the same thing will not be in motion or at rest for another person. For example, suppose there is a car, okay, and this car is moving very smoothly on a road, and there is a person on the ground, right? There is a ground observer, and let's say there are two observers in this car. Let's say observer A and observer B, and this is observer C. The observer C observes A and B, and observers A and B also observe C. For this person, A and B are in motion because obviously they are changing their position over time. But now for A, the B person is not in motion because for A, the position of B is not changing, right? Okay, the amount by which A is going forward is the same for for the observer B. The observer B is also moving forward with the same amount. So for A and B, for each other, both of them are at rest, not in motion. But for C, both of them are in motion, right? Now you can see the person A is at rest with respect to B, but the same person is in motion for this person C. That means motion and rest are relative terms. They are not absolute. They depend on observer, right? Okay, so this was the one thing that I wanted to tell you. And another thing is something called as reference frame. So what is a reference frame? So let's look at that. What is a reference frame? A reference frame is a world view of an observer. What do I mean by this definition? See, I will tell you. So any observer in physics, he has been given a clock with him, right? And he has an idea of spatial dimensions, that means the space dimensions. For example, if I have a person over here, the observer, this observer is sitting at some point, let's call it as origin, and this is your one dimensional line. Now some event occurs at this position, let's say x equal to 100 meter. Some explosion occurred at this position, right? Now this observer will measure this distance to be 100 meter, and also if he starts his clock at some time t equal to 0, right? T equal to 0 does not mean the origin of the universe or world, not like that. T equal to 0 means the beginning, the time at which he just starts his clock or stopwatch, whatever. So after starting his clock, maybe after 10 seconds, this explosion took place at 100 meter. Now he can convey this information to another person by saying this, that some explosion occurred at 100 meter plus 100, because it is right direction. If it happened on the left direction, it would be minus, right? So it happened plus 100 meter and at a time 10 seconds. So he has the information not only in space but also in time, right? Okay, so these are the two dimensions. One is a distance and another is time. Another example of a reference frame is a 2D reference frame, little complex reference frame, right? X, Y, and some event occur here. So you have to provide X and Y, these position coordinates, as well as the time t, right? So here you have to provide 3 coordinates. So this is something called as reference frame, right? Okay.